Hello everyone, my name is Saurabh Singh and today I am going to teach about the soil index properties. It is unit number 5 and this will be lecture number 35. After watching this video, if you have any doubt, you can contact to me and you can also write email on saurabh.singh@mygyanviha.com. Come on the learning objective and learning outcome here. The learning objective to provide the knowledge about the soil index properties, which is very important for the all civil engineering students. And in learning outcome, student will learn and understand the theoretical knowledge about the soil index properties. By this lecture, you will know about the what are the index properties of soil and how to use these properties in the geotechnical engineering. And now we will see the purpose of soil classification system. Classification of soil into groups, subgroups with the similar engineering behavior. Classification system were developed in the terms of indicate GSD, and as I told you earlier, this classification can provide geotechnical engineering with the general guidance about the engineering properties of soil through the accumulated experience. And as you can see here, this is your flow chart of a soil classification system where what is the need, which is showing the need of soil classification system. In this here we will see these soils, and these soil are categorized into many parts, and there is also many reason of the failure of structure due to the soil behavior. And if you think, if I give you a bag of if I give you a bag of 1 kg soil taken from an under construction site and asked you following question. So by this you will learn what is the meaning and what is the basics of a soil classification system. That's why these questionnaires have been written here. I did this questionnaire for your understanding, basic understanding. A question is given here. If I give you a bag of 1 kg soil taken from the under construction site and asked you following question, what is the most basic classification of soil? What are the method of soil gradation and grain soil distribution? How do you define the soil of types? And clay, silt, sand, gravel, cobble, and boulders. Calculate D10, D30, and D60 for this soil by the using of Sieve, and calculate both Cu and Cc of the soil. Is this soil poorly gap or will grade loose soil or granular soil? As you can see this graph is showing the different volume reduction in the granular soil. As you can see in the figure 1, there is more this is not more compacted soil, that's why there is more white. There is some compacted soil, that's why there is some air voids which is less than this graph, and this is fully compacted, and we can also call it densest state soil where is less soil, and you will say it is in loosest state and it is in intermediate stage, and this is in densest stage. And this diagram is showing volume reduction from the compaction of granular soil. Now dr can be expressed either in the terms of void ratio or dry density. Dr will be equal to E max minus E max minus E minimum, where Dr is representing relative density, usually given as a percentage. E in the site void ratio of the soil is the maximum void ratio of soil in the loosest state, and E minimum is the void ratio of soil in the densest state. Now we will see some derivation. You can solve this derivation by using this formula. And granular soil and quantitatively described according to their relative densities, which is shown below. As you can see, there is relative density is given of very loose soil, medium soil, dense soil, very dense soil. And the use of relative density has been restricted to granular soils because of difficulty of determining Emax in clay soil. Liquidity index in the fine soil of is similar use in DR in the granular soil. There are some remarks which you need to know. The relative density of natural soil, very strong effect in the engineering behavior. The range value of dr may vary from minimum of 0 for loose soil maximum to 100% for heavy dense soil. Because of the irregular size and shape of granular particle, it is not possible to obtain zero volume of. You can see here, they have to put it on the soil and they will put it out. Then they have to take the soil sample. The core, which will be include soil plus brass cylinder, is oven dried at 105 degrees Celsius to remove non-structural soil water till the mass remain constant, usually after 24 to 28 hours. Now you can see these are the some equipments which we use in the core cutter method for determination of bulk density of soil. As you can see here, that is your cutter, and from this cutter we have to take the sample like this, and which will be undisturbed soil sample, and this is then it will go in the dry oven at the 105 degrees Celsius. After that, do the weight of this soil sample, and we have to remove the moisture content. And here you can see the volume of cutter will be equal to volume of T will be R square pi H. This is a simple formula of determining the volume of a cylindrical thing. Now we will see the example of a core cutter method. Here is R, which is given here 3 centimeter, H is given 12 centimeter, and MS is given 480 gram oven dry mass. And VT will be become here R square pi H, which will be become 3 square 3 into 14 into 12. As you can see here, this is your 3.14. This is your value of pi, which you can see here, and it will become 339 centimeter cube. From here we have to find rho PB, which is bulk density. Bulk density will be mass of solid upon mass of volume of sample will be equal to total volume, which will be equal to 480 gram upon 339, which we determined volume already here, and mass we already given here, and it will become 1.42 gram per centimeter cube. That will be your bulk density of soil. This example is very important. If you will write any government exams, these types of question and examples may be asked to you. And this is, as you can see, this is a very easy. By this formula you can easily determine the total bulk density of soil. From here you have to calculate the volume of your cylindrical cone, which will be equal to R square pi H, and it will become here 339 centimeter cube, and mass is already given here, which will be equal to density will be equal to mass upon volume. Then we will get 1.42 gram per centimeter cube. Now we will see the excavation method of by the sand funnel. The quantity of soil is excavated in the field dried at 105 degrees Celsius and weight. The volume is determined by the filling excavated hole with the well-defined standard sand, of which volume per unit mass is known as sand funnel method. As you can see, this is your sand funnel method, which is used for the excavation purpose. Now, excavation method, you will also see there is also one rubber balloon. In the rubber balloon method, the volume is determined by the inserting the balloon into the excavation and filling with the water and other fluid is known as density. As you can see here, that is your water towel, and that is your valve, and that is your rubber membrane, which is fit on the end of this scale, or you can say this is this water tower. Now we will see the next topic here, engineering classification of soil. This is also very important, and we have done some points in the previous lecture. So let's see again what is the engineering classification of soil. What is the purpose of doing the classification? Classification soil into group and subgroup with the similar engineering behavior. classification system were developed in the term of simple indicate which is showing GSD. And now we will see the purpose of soil classification system. Classification of soil into groups subgroups with the similar engineering behavior. Classification system were developed in the terms of indicate GSD, and as I told you earlier, this classification can provide geotechnical engineering with the general guidance about the engineering properties of soil through the accumulated experience. And as you can see here, this is your flow chart of a soil classification system where what is the need, which is showing the need of soil classification system. In this here we will see these soils, and these soil are categorized into many parts, and there is also many reason of the failure of structure due to the soil behavior. And if you think, if I give you a bag of if I give you a bag of 1 kg soil taken from an under construction site and asked you following question. So by this you will learn what is the meaning and what is the basics of a soil classification system. That's why these questionnaires have been written here. I did this questionnaire for your understanding, basic understanding. A question is given here. If I give you a bag of 1 kg soil taken from the under construction site and asked you following question, what is the most basic classification of soil? What are the method of soil gradation and grain soil distribution? How do you define the soil of types? And clay, silt, sand, gravel, cobble, and boulders. Calculate D10, D30, and D60 for this soil by the using of Sieve, and calculate both Cu and Cc of the soil. Is this soil poorly gap or well graded, liquid limit, plastic limit? How do you define these terms? Means these are the basic questions which is very important for every civil engineering student, because when you will go for your work, when you will get a job, when you will do a work on your field, then these types of questions can be asked by your senior, and there will be a need there. You should answer all these questions. You have to answer all these questions, and you will learn today in this class what is these meaning of these questions. First, we will see sieve analysis. What is the purpose of doing sieve analysis? This test is performed to determine the percentage of different grain size contained within a soil. The mechanical or sieve analysis is performed to determine the distribution of the coarser, larger side particle, and hydrometer method is used to determine the distribution of the final particle. What is the significance of sieve analysis? We will see here the distribution of different grain soil affect the engineering properties of soil. Grain size analysis provide the grain size distribution, and it is required to classifying the soil. These are the major group of the soil group. As you can see here, cohesive soil, granular soil, cohesionless soil. There is silt, clay, sand, gravel, cobble, and boulders. These are the grain size soil. Soil particle classification is given here, and these are the organization which given method in the soil classification. Now we will see the grain size distribution, which is also known as GSD, and we will see what is the significance of a GSD to know the relative proportion of different grain size. An important factor influencing the geotechnical character of coarse grain soil, not important in fine grained soil. These are the significance of a GST, means grain size distribution. Now we will see the how to determine the grain size distribution, how we perform this test. In the coarse grain soil, by sieve analysis, fine grain soil by the hydro analysis. As you can see, if soil will be coarse grain, then we have to do the sieve analysis. If the soil grain will be fine, we have to do hydrometer analysis. And as you can see here, this is the hydro method, and this is your image of a cement lashes. Cement lashes where gravel will be here, sand will be in this sieve, and fine soil will be in this seal. Now you can see the image of ISC, which is here, and these are the sieve ISC which have different size. Now we will see the sieve designation. What is the meaning of large sieve designation? As you can see, this is the size of this sieve is 3 inch, and this is larger. This is used for the larger size boulders, and this can be also used in the sieve analysis. Now sieve designation, we will see here. If smaller sieve are numbered according to the number of opening per inch, HE. Now we will see the head differentiate between soil and now we will see the head differentiation in the soil sample. As you can see here, what caused the flow of water through the soil. As you can see here, that is difference in the total head. Here, that is your soil sample, and there is also hydraulic gradient, which is represented by the I, and there will be Q is equals to V dot A. V means velocity of flow, and which will be equal to KIA, and K will be KIA will be written as the K upon H upon delta H upon L, and there is I is the hydraulic gradient. Now the loss of head A and B can be given by the how you will calculate the loss of water. Here you can do by this formula, by using of this formula, which will be delta S is equals to HA minus HB is equals to P upon gamma W plus ZA minus PB upon gamma W plus ZB. And delta H can be expressed in the non-dimensional form as the hydraulic gradient, and hydraulic gradient will be equal to I equals to delta H upon L. Now in the journal, the variation of velocity V with the hydraulic gradient I will be shown as in the figure below. As you can see, that is your hydraulic gradient that is showing your velocity. And in the most soil, the flow from the water through the void spaces can be considered laminar, and they because of V will be directly proportional to I. Now we will see the Darcy law. What is the Darcy law? In 1856, Darcy published a simple equation for the discharge of velocity of water through the saturated soil, which may be expressed as the V equals to Ki. V means discharge velocity, which will be equal to quantity of water flowing its unit time through a unit gross minus sectional area of a soil at the right angle to the direction of flow. And K will be equal to coefficient of permeability. That is your formula which we use to find a discharge of a soil by the using of Darcy law, which is equal to V is equals to K square. V is directly proportional to I, and there is a K which is called coefficient of permeability. And here we can see in the based of gross sectional area the soil. However, the actual velocity of water seepage velocity Vs through the void spaces is higher than V. This can be derived as a following. As you can see, that is your soil sample and that is your flow rate, and we have to calculate the flow rate from the this side to this side. And how it will be calculated? And it will be calculated in the soil. And as we all know, there is a calculation of speed, which is known as distance upon time. Then we have a length of sample is here, which we assume as a distance of a water flow, and that is your area of a soil specimen, which will be shown by A, and that is area of void in the cross section, which is shown by the AV, area of the soil solid in the cross section, which is shown by the AS. Now we will see what is the flow rate in a Q. Then Q is equals to VA, as we all know, and it will become AB upon AV into VS, and we can write A as a AV plus AS. So that's why Q will be equal to V bracket close, AV plus AS bracket close will be equal to AV into VS, and VS will be equal to this, and by this, by the using of this formula, we will find VS is equal to V upon N, where this V is the capital. And now we will see the how to measure a horizontal flow of a water through the soil sample. This is the velocity, where we will calculate the velocity, and this is your head of center of the soil sample. As you can see, this is your head of a soil sample, and that will be air pressure, from where we will calculate the air pressure, and that is our datum. Now we will see the one example here. In the case of air pressure, will produce a required head for the horizontal flow. So total head velocity will be 23 upon 4, and 9.8 will be equal to 2.358 meter, and that will be calculated here 2 centimeter per second. Now we will see the downward flow. What is the downward flow? As you can see here, that is your datum, that is your elevation, which will be represent, the unit of elevation will be in meter, and there is the total head and elevation head. And now by this formula, you can easily calculate the head, and which will be the one will be the equal to 1 centimeter per second at the entrance and the exit part of the tube, and it will be 3 centimeter per second through this soil sample. Now we will see the upward flow. What is the upward flow? The some tube was tested under the upward flow as shown in the figure below. As you can see, and V will be here equals to Ki will be equal to 0.33, and here you will find Vs is equal to 1 centimeter per second, and there is also hydraulic conductivity and coefficient of permeability, which we represent by the K, and it is defined as the rate of flow per unit area of a soil under a unit of hydraulic gradient, and it has a dimension of velocity, which will be equal to L by T, and will be unit of it will be centimeter per second, and we can also calculate it in feet per meter second. It depends on several factors as follow. First one is shape and size of the soil particles. Second, distribution of soil particle and pore spaces. Third one is void ratio, permeability increase with the increase of void ratio. Fourth one is degree of saturation, permeability increase with the increases of the degree of saturation. Fifth will be the composition of soil particles. Sixth will be soil structure. As you can see, this is your fluid property. When the properties of fluid or water affect the flow are included, we can express K by the relation. K will be equals to K. The unit of K will be here centimeter per second, and here you can see the P is equals to mass density of fluid, G is equals to acceleration due to the gravity, which will be the measure in the centimeter per second square, and mu absolute velocity of fluid, which will be which also called poise. Now you will see varies widely different soil. K varies in different soil, and it is shown in the table. The value of K will be different in the coarse aggregate, and it will be also different in the fine aggregate, and it will be also different in the dense silt and clay silt. So we will see what will be the value of K, and this is a very important point which you need to remember always, because without the coefficient of permeability, you cannot calculate the total permeability of soil, and you can also not calculate the seepage amount of seepage of water through the soil structure. So you can see here, that is your soil type. There is coarse gravel, fine gravel, coarse and medium sand, fine sand, loose silt, dense silt, clay silt, and silty clay and clay. Here, K is given, and K will be calculated here in the per second, which will be in coarse gravel. It will be equal to 10 to 10 to power 3, and in fine, coarse, and medium sand, it will be equal to 10 to power minus 2 to 10, and in fine sand or loose silt, it will be equal to 10 minus 4 to 10 minus 2. At dense silt and clay silt, it will be equal to 10 to power minus 5 to 10 to power minus 4. And in silty clay or clay, it will be equal to 10 to power minus 8 to 10 to power minus 5. The coefficient of permeability The coefficient of permeability. The coefficient of permeability of soil is generally expressed as the temperature of 20 degree Celsius and at any other temperature T. The coefficient of permeability can be obtained from the equation 12 as the K20 is equals to KT, where KT and K20 will be coefficient of permeability at the uh, T degree Celsius and 20 degree Celsius respectively. And here you can see Pt and P20 will be equal to mass density of fluid at T degree Celsius and 20 degrees Celsius respectively. And mu2, mu T and mu20 will be the coefficient of velocity, viscosity at the temperature T and 20 degrees Celsius respectively. Since the value of P2, P20, Pt is approximately 1, it can be written as the K20 is equals to Kt upon Kt mu T upon mu 20, where Ut upon mu 20 will be F into pi bracket T, which will be approx 1.628 minus 0.0433 T plus 0.00046 T square. Now we will see the laboratory test. What is the laboratory test for the permeability? How you can measure the permeability of a soil in the lab, and what kind of test you have to perform in the field. So we will see here there are four most common laboratory method for determining the coefficient of permeability and in the soil, which are given as the, and which one is, first one is constant head test, and second one is falling head test, and third one indirect determination from the consolidation test, and fourth one is indirect determination by the horizontal capillary test. Here you can see the laboratory test, which will be equal to constant minus head test, which we can write here capital Q is equals to small qt is equals to KIAT, and K here will be OL upon HAT. Here you can see here suitable for the cohesionless soil with the permeability which will be greater than 10 to power 10 to power minus 4 centimeter per second. The simple list of the all method for determining coefficient of permeability. The test is performed by the measuring the quality of water Q flowing through the soil specimen, the length of the soil specimen L, and the head of water. Now we will see the some example of permeability. How we will solve the examples of permeability? We will see here. As you can see, the following figure shows the layer of soil in a tube 100 mm into 100 mm in the cross sectional. Water is supplied to maintain a constant head difference of 300 mm across the sample. The permeability of coefficient of soil in the direction of flow through the follows. Find the rate of supply. As you can see here, that is your water supply, that is second water supply, and that will be your soil sample here. And what we have to measure, and the total distance will be traveled by the water will be 150 into 150. It will be equal to 450, and that's why we need to calculate what will be the discharge of water here and what will be the permeability of this soil. So as you can see here, soil is equals to divided into A, B and C, which is A is given 10 to power minus per second, minus 2 second, which is the coefficient of permeability, A B in B 3 into 10 to power minus 3, and C 5 into 10 to power minus 4. Solution, how we will solve this for this example, we will see here. For the soil layer B and C, the flow is parallel to the stratification, and it will be the formula of the solving this equation for the layer of A, which is equivalent layer of B and C. Here K equation will be become here H by H1 minus K1 plus H2 minus K2, and it will become 3.8 into 10 to power minus 3, and K will be converted in centimeter per second, which will be equal to 0.003888 centimeter per second. And Q will be, as we all know, the formula of Q is equals to K equivalent I into A, which will be equal to 0.003888, and it will become 0.259 centimeter cube per second. Now there is also some different example which we will also see. The permeability of coefficient of sand at the void ratio of 0.55 is zero point 0.1 feet per minute. Estimate the permeability of coefficient and avoid the ratio of 0.07. Use the Casagrande empirical relationship. What is the need of solving this question? When things can be came in your mind why you need to solve this question, but by this question you will understand how you will use the permeability in the geotechnical engineering and where is the application of permeability and leakage. If suppose you are doing a work in the construction structure like a dam where you need to find the permeability of that soil, then this example will help you a lot. Here is the solution from Casagrande relation where k is equals to 1.4 e square k 0.85 will be where k will be directly proportional to e square, and here will your answer will be e will be 0.07. For normally consolidated clay soil of following are given. The void ratio is given here 1.11 0.9, which is equal to 0.302 into 10 to power minus 7, 0.12 into 10 to power minus 7, and estimate the permeability of coefficient of clay at the void ratio of 1.2. Now we will solve this question by this formula. As you can see, Samar Singh et al. This is a et al. This is the paper journal by there. These formula are given. Now we will see the next question. What kind of next question is people pumping test from the gravity well is permeable layer and underlain by the previous stratum was made. When steady state is reached, the following observation were made. Q is equals to 100 gram per meter. H1 will be equal to 20 feet, H2 will be equal to 15 feet, and R1 will be equal to 150 feet, and R2 will be equal to 50 feet. Here is asking determine the permeability of coefficient of the permeable layer. Means which soil we are using that is already permeable. So you need to find what will be the coefficient of permeability of this soil. Now by the using of this formula, you can easily find the permeability of the layer. Now we will come on the seepage. What is the seepage? As you see, as you can see here, in Laplace equation of continuity, there is seepage is given, the formula of seepage is given. And what will be the definition of the seepage? Here you can see in many instances, the flow of water through the soil is not one direction only, nor in the uniform over the entire area perpendicular up to the flow. In such cases, calculation of groundwater flow is generally made by the use of graphs referred as to flow nets. The concept of flow net is based on Laplace equation of the continuity, which is described as the steady flow condition for a given point in the soil mass. And there is also derivation, which you can see here. To derive the Laplace differential equation of continuity, let us take a single row of the seed piles that have been driven into the permeable soil layer as shown in the figure below. As you can see here, that is your impermeable layer here, and that is your seat, and we have to calculate the seepage through the here, and we will also find the inflow rates of a water. Now we will see the assumption of a seepage. As you can see, the row of seed piles is impervious. Impervious, the steady state of flow of water from the upstream to the downward or downstream side through the permeable layer into two-dimensional flow. The water is incompressible, and last one will be the no volume changes occur in the soil mass. Thus, the total rate of inflow should be equal to the total rate of outflow. Now this is the problem. This types of problem came in the seepage through the soil, and that is will be solved by the continuity equation for the solution of this simple problem. Here continuity equation will be used. As you can see, there is a soil sample 1 which is equal to Z is equals to 0, H1, H is equals to H1, Z is equals to H1, and H2 is equals to S2. By this formula, you can easily determine the seepage of a soil. Now, what is the flow net? The following method are available to determine the flow net. And what is the use of flow nets? You can see here graphical solution by the sketching, mathematical or analytical method, numerical analysis and models, analogy method, and all methods are based on Laplace continuity equation. Flow nets, you have to also need to determine what is the flow nets. You have to find the use of flow nets in the water. As you can see, there is one equation which is given here, flow net isotropic medium, and it represents two orthogonal families of curve. Thus is flow lines and the equational line. Flow line, what is the flow line? First, we need to know flow line is the line along which the water particle will travel from the upstream to downstream side in the permeable soil medium. And equipotential line is the line along with the potential head of the all point is the same. These two definitions are very important for a geotechnical engineering student, because these question and these definition will definitely come in your exams. And this is the experimental setup for a calculation of flow net of a soil sample. Now, as we can see, the combination of number of flow lines, equipotential lines is called flow net. The constructive flow net, the equipotential line are drawn. As you can see in the above figure, the equipotential line intersect the flow lines at the right angle. The flow element formed in the approximately expire. The following figure shows the another example of the flow net in an isometric permeable layer. This is your diagram, which is impervious material. As you can see, that is your dam, and there will be some flow net in the downward direction. And there will be, now we will see the MCQs, which is given here. And first question will be, talus is the soil transported by. What is the talus, how it became in the soil? So we have to give the answer. It became by the effect of water, and it became by the effect of wind, or by it became it by the effect of glacial or gravitational force. Here we need to do answer this question. Here, as you can see, talus is the soil transported by the wind, and talus will be the transported by water or glacial or gravitational force. Here, right answer will be the glacier. Means talus is the types of soil which is transported by the glacier. So this is the very important questions, and this question has been came in many exams, in government exams, and it may be also came in your weekly test. That's why this question has become very important. Now there is the next question, which is the capillary rise of water will depend on what will be the capillary of rise of water. So first you need to know what is the rise of water. As you know, what is the capillary action? Suppose if you will put a brick in a water body, what will happen? Or water will come on the upward side of the brick. If you will put a brick in the water, what will happen? You will see after 1 day, your water will came on the top of the brick. That is called capillary action, and that is also similar to capillary rise of water. What is the reason, and on which things the capillary rise of water is depend upon the force of responsible increase as the size of soil particle increase, decrease as the size of soil particle decrease. Next one is it is less in wet soil than the dry soil. So we will see here what will be the right answer of this question. The right answer will be here, decrease as the size of soil particle decrease, and it will be increase as the soil particle increase. Now we will see the next question. If there is no impervious boundary of a bottom of hydraulic structure or streamline trend of the follow, what will be our right answer here? A straight line, a parabolic, a semi-ellipse, a semicircle. What will be the right answer? Right answer here will be C. As you can see here, it will be semi-ellipse. Now come on the next question. For a slope of limited extent of a surface slippage is usually along, what will be the right answer here? Option is given here: a parabolic arch, an elliptical arch, a straight line, a circular arch. So right answer here will be a circular arch. As you can see, this for the slope of limited extent of surface of slippage is usually along with the circular arch. Here your right answer will be D. Now come on the next question. The next question is the compression index of soil, which is given here: decrease with the increase in this liquid limit, increase in the liquid limit, and decrease in and increase in the plastic limit. It is not related with the plastic limit. So one things you need to also know, we can easily determine the liquid limit by the Casagrande apparatus, and Casagrande apparatus is very useful to determine the liquid limit and water quantity of a soil. So here will be right answer: increase with an increase in the liquid limit. So the question was the compression index of soil will increase with an increase in the liquid limit. That is your right answer. Now come on the next question. The pneumatic tide roller they are useful or compacting. What will be the right answer here? We will see here. Right answer here will be A and B both. And as you can see, 4 option was given here: cohesionous soil, cohesionless soil, both A and B, and for soil confined space. So right answer will be here C, and it will be your right answer. Now next question is quicksand. What is the quicksand? It's a type of sand, a condition in which cohesionless of soil lose its strength because of upward flow of water. C is given here: a condition in which the cohesion soil loses its strength. And next one is none of the above. This is very important question, and this question came in the many government exams. So here, as you can see here, right answer will be quicksand is a condition in which the cohesionless soil loses its strength because of upward flow of water. That will be your right answer, and this is very important question. And this types of question also came in your SSC exam or in many state government exams. So this question is very important, and here you can also see the definition of quicksand. And if anybody will ask you what is the quicksand, you can easily answer: a condition in which the cohesionless soil loses its strength because of upward flow of water. So come on the next question. In the fine sand and silt, the most common type structure is. What will be the right answer here? Single grain, honeycomb, flocculent, or dispersed? And here right answer will be honeycomb. As you can see here, in the fine sand and silt, the most common type structure is honeycomb. And come on the next question. The starting point of a horizontal drainage is usually taken as a parabola. What will be the right answer? Option is given: focus, origin, vertex, both and a B. And here right answer will be both and A and B. Now come on the next question. Stability analysis in the terms of mobilized shear strength is referred as shear strength, maximum shear stress, applied shear stress, none of the above. Let's see what will be the answer. Here answer will be applied shear stress. In stability analysis, the term mobilized shear strength is referred as applied shear stress. That will be your right answer. Come on the next question. The minimum allowable factor of safety against sliding into the case of cantilever retaining wall. Here, what will be the right answer? Option is given: 2.0, 3.0, 1.50, 2.50. Right answer here will be 1.50. And the minimum allowable factor of safety against sliding in the case of cantilever retaining wall is 1.50. Now, this lecture is over, And this here we covered the seepage and permeability. We also saw where permeability can be applied in the soil and how you will solve the question of permeability and seepage, and what is the basic difference between permeability and seepage, and how you will perform the test of permeability in your geotechnical lab. This is your geotechnical book, which is written by the VNS Murthy, and there is also NPTEL link, which is very useful. If you will watch this video on NPTEL, you will also get the basic idea about the permeability and seepage, and this is the most important topic in the geotechnical engineering. This lecture is also important for the diploma engineering who is doing diploma in civil, and it is also very useful for MTech who is doing MTech in geotechnical engineering. Thank you for watching this video.